So, welcome. Hi. Yay. Oh, cool. Yeah, I'll have to check that out. And, yeah, happy Tuesday. Welcome to the episode club. We are going to be talking about Battlestar Galactica. Whoop whoop. Oh, hello. Happy to have you here. All of 15 feet, 20 feet, 25 feet, probably a little bit further away from me. Downstairs, at least. But we are going to be talking about Battlestar Galactica and the mini-series, of which Jed AK-47 and I watched last night. Not for the first time. We've seen it before, but refreshing our memories. So, excellent series. We came to decide on watching this because through the patrons, through my Patreon group, which you can find a link down below, we hold a vote to decide what we want to talk about every week. And the last couple weeks, we had a tie between sets of episodes. And then this week, we had ties. A tie between Battlestar Galactica, the miniseries, and Avengers Endgame. So we are going to be talking about Avengers Endgame next week. Get the emotional support tissues ready. I'm going to need that for sure, but it's gonna be awesome. But we are here to talk about Battlestar Galactica, so say we all. Awesome series, so fun to watch again, so cool. Now we'll go through it kind of chronologically through the 3-hour mini-series. So this is the one that aired before they actually jumped in. So if you watch Battlestar Galactica Season 1, Episode 1, that's usually not what you want to start with. It's the Battlestar Galactica mini-series. So if you're watching this after the fact, or if you're watching it now and you watched the wrong one, go pop over, watch that, come back later, and we can talk about the mini-series. Now there's some highlights in here, some technology that they introduced that you see throughout the entire series. So we will be hitting on the star system that they're in, the FTL jump drives, mostly. There's some really cool science behind that. Some of the science consultants that worked on this were Kevin Grazier, who I've met. If some of you Dragon Con folks will have met him before. And Jane Espenson also worked on this and did some of the science behind it. So, some really cool stuff. There are some fun little Easter eggs in Battlestar Galactica as well. If you hadn't watched it before or were new to it, you notice that all of the corners on the pages are all clipped off. And there's a long running sort of apocryphal story about that they were told that it was too expensive and they were told to cut corners. And so as a cheeky response, they went and cut all of the corners off all the pages. And it ended up being one of the most most expensive things that they did, because then they had to go through and make frames and make clipboards and everything with all the little corners cut off. Yeah, it's pretty fabulous. So if you hadn't noticed that, that's kind of the story behind that, which is still awesome and iconic. But we kick off, and Cylons were a thing of the past. It's been over 40 years since the Cylon War, and they kind of show a nice little nod toward the old Battlestar Galactica Cylon Centurions that we've seen and know and love, and or are deeply afraid of, our chrome toasters. And the humans have a station set up for like an armistice treaty negotiations where they can meet every year. And the Cylons have never showed up until now. And we have Caprica City. We get to see Caprica City, which is a big, bustling, futuristic sci-fi city, which is pretty cool. They have shuttle traffic that goes overhead with downward exhaust. Oh, hey, Brad, welcome. Yes. That you get to see these vertical takeoffs is kind of their local shuttle method for going around, which is kind of neat. And we get to meet our space mom, Laura Roslin, who is fabulous, and we love her. Played by Mary McDonnell, who is also fabulous, and we love her. And we see her, we get introduced to her as a character, and then she gets in a passenger shuttle airplane type thing that goes to the Battlestar Galactica. And it takes 5.5 hours to get there. So it's reasonably-ish close to the planet, but you can imagine that they probably have some advanced form of travel. It's not quite faster than light, but it's pretty fast to be able to travel in space that quickly, because we're not really close to that. And they are definitely further away than low Earth orbit. So they definitely have advanced propulsion travel techniques that's going on. They do make the point of noting that the Battlestar Galactica is technologically ancient, thanks to our good Captain Adama, who is fought the Cylons and has nothing to do with computers and networks and wants nothing to do with it. So they have no automated approach or guidance for their flight systems. They have to manually land. So anything Wi-Fi, wireless, Bluetooth, any technology like that does not exist on the Battlestar Galactica. They do have things like they do have legitimately computers. They legitimately have technology, but it's just not actual networked systems. Kishore, thank you for the following and welcome. So yeah, it depends on the frequency, and it depends the level of data that you're using to actually transfer packets. So yeah, he straight up rejected upgrades. All the other Battlestars and all the other so the Battlestar Galactica is being decommissioned. That's kind of the kickoff of the story, that it is being turned into a museum, as they frequently relate to, but they definitely say like they have never upgraded the computer systems. And they even say it later with Gaius Baltar when he's on the Battlestar Galactica, and he's going through their code base, and it is like, we'll get to that in a second when they talk about the Mark IIs and how the Cylons can take them out. But he explicitly says, like, this code was made available to the Battlestar Galactica and they never actually implemented it. So, all right, Zach, go enjoy your pizza. So yeah, that's exactly it. And we'll come back to it when we talk about the Mark IIs and the Cylons. So, with that, not networked, no integrated computer network. Gaius Baltar, I mean, credit to him, right? Like, credit to the actor that character, and the writing, that character just kicks off being his Gaius Baltar self from second one. And, I mean, he's fabulous, but he's got, as we like to say, a punchable face. And he has been sleeping with, as we then find out, is a Cylon. Caprica 6 is kind of what we call her throughout the series. But she used him to access the Caprica at the Colonial Defense mainframe. So she has got into their networks and their systems, and they bomb the crap out of all the planets, is basically what happens. Nuclear bombs start going off left and right. So a little bit of science behind nuclear bombs, and this starts to get very stressful and very depressing, so we're not going to dwell on it that long. But they do have some interesting facts associated with it. So, nuclear bomb goes off. We see these happen. Now, with Gaius Baltar, he's watching theirs. I would love to study the psychology behind the punchable face, and I think that we need to talk about that at some point. But he's got a punchable face, and I will say that with good authority. So, the nuclear bombs start going off. She basically tells Gaius that, hey, we're in. Thanks a lot, bro. Yeah, I'm a Cylon, and you are responsible for all this stuff, and your entire planet's about to be wiped out. And then he's like, oh my god, I'm going to get in so much trouble, because he's Gaius Baltar. And she's like, no, everyone's going to die. So the nuclear bombs start going off. There's some interesting stuff here. First of all, one nuclear bomb does not take out the entire planet, which is good. I think that we do see that in science fiction sometimes, that they overestimate the amount of big, scary weapons that are required to wipe out entire planets. It takes a lot. Planets are big, especially planets that will have Earth-like gravity, that will be big enough, massive enough to have what appears to be Earth-like gravity. It's going to take a lot of nuclear bombs to wipe out a good portion of the planet. So you do see it before you hear it or feel it. So there are different stages to nuclear bombs. If you see it, you will survive. You will get hit with radiation. So they actually do a good job where he gets the flash. Welcome back. He gets the flash, and it's called flash blindness. And he gets flash blindness because it is so bright. It's such high energy photons, and it's such a bright light that it does actually blind you. And it can last for seconds or up to minutes, or be permanent if you were close enough. Chances are, if you were close enough, you're still going to be in kind of a danger zone. And his house was not exactly set up to sustain a nuclear blast, as we saw. Lots of windows. You don't want a lot of windows. If a nuclear blast happens, if you do get a warning of a nuclear blast, go inside. Go far inside. It's amazing how much strong concrete buildings can help you. Do not go to your car. Your car will not help you. We are not going to dwell on this too long because it's way too stressful to talk about these days. but high energy photons will get you. The flash blindness gets you. The shockwave will hit. For them, it hit about 10 seconds later. So you can estimate that they were probably within 10 miles away of that particular one that took him out. I think it's safe to assume he does not live in a hurricane-prone area either. Although, being Gaius Baltar, I could see him just being like, well, I'll just build a new house. I have insurance. So the shockwave does hit, depends how close you are. I think for this one, I would estimate that they were within 10 miles. But the good thing is that they didn't, at the very least, the sound at least accompanied the shockwave, because the shockwave is going to kind of carry sound with it, right? Because sound is a compressed wave, and so you are going to get a big compression of air. So technically that's a sound wave, even though it is too high to hear. It's not an audible frequency, but it does fit the definition of a sound wave. And then, yeah, there would be sort of remnant sound afterwards. So it just depends. But yeah, supersonic, exactly. If you were close enough, that's exactly what it would be. So, all not good things. But nuclear blast happened, takes out Caprica. We find out all of this stuff is going on. They get notification that this is happening. One of the cool things is that they start to, so now nuclear bombs have gone off. The notification goes to like the fleet, to other planets. People are communicating and informing them what's going on. Initially, they think that it's a retirement. Colonel Ty thinks it's a retirement prank for Adama, but he's less than reliable. And I know I should show more respect to the EXO, but he's less than reliable. And he thinks that it's a retirement prank for Adama because it's a Cylon attack, and that's a big scary thing that you didn't think would happen. Just saying. And so they start engaging. Cylons start coming up and start engaging with the spaceships that are out there. I mean, this is like a coordinated, sustained attack. This is meant to happen all at once. That they bomb the crap out of the planets, and then they send in their fighters to take out all of the spaceships that are out there currently. Now, they have all of these Vipers, the jets that are there. They don't have a lot of them. But the ones that they do have, they take out to engage the Cylons, and they all start malfunctioning before engaging, and they basically get hit. The Cylon eyes do the vroom, vroom, and then their ships go poof, and it's basically like an EMP that hits. It's like a interference that took down their electronic system. So the view from space of the bombardment would look like that. That's a good question. I mean, we don't have a lot of good imagery of nuclear bombs going off from space, but it does look, I mean, you do look at a planet and then you see his bombardments, and the clouds are huge compared to kind of what you think it would be, sort of a size ratio. So I think it's exaggerated compared to what it would actually look like, but it's an interesting point. In terms of what happened in the original series, no, I think that they got in the original series, I don't remember how it kicked off. I have not watched it beginning to end, fully admit. The original series. I've watched the reboot a couple times, and then I get sad, and then I stop, and then I restart it, and then I remember that I get really sad, and then I stop again. So I don't remember if they were always at war, or if they do, if it kicks off with something similar. I know this deviated a little bit away from it, but because it's kind of meant to be like a quasi sequel they implemented there. But anyway, so they start fighting them, and the Cylons actually take down all of the, and thank you for the follow, by the way, and they take down all of the electronics on these Vipers. Now, one thing I really like is that they can pick up the Cylons on the radars. They pick up signals that there is something there. So remember, radar is radio waves that are being bounced off, and it looks like pretty old school traditional radar that they're using. So they can get some ping on these Cylons, but they're dark and they're hard to see. And when you first see them, when they first engage, they come out from the sun is behind them, which is objectively awesome to see. But then it's really hard to detect them. But because also it's important to note that they are really dark, and it's really hard to see things in space. Space is dark and cold and scary. And usually the best way you can detect radar is helpful if you're close by, but typically we look for, and it's big, typically we look for something like this. You would want to look for the infrared signature, right? So you would want to see some, even if it's like completely opaque visually, like it's dark and blends into the background, if it has some residual heat from the electronics, then you'd be able to detect an infrared signature to pick up on it. But if it comes from the sun, it's going to be almost impossible to detect. So yeah, thermal scanning from Mass Effect would work better. Thank you. That's an excellent point. So all awesome. The fight battles in Battlestar Galactica are freaking amazing. Let's just take a second to appreciate that. One thing I love is that they treat space like the three-dimensional, cold, dark, scary, big place that it is, but they fight in 3D. You know, you have Boomer and Hilo. They basically have this support ship that they're using as to do all of the radar, to do the assessment of the area and everything, and then they peace out and they go up and get out of the way so they can engage, because space is three-dimensional, and it's brilliant. Yeah, that's a really good point. The infrared sun-moon blinding is a concern that we have to mitigate when it comes to satellite control. That's an excellent point. Thank you. But yeah, they have 3D, and not only that, they have those like little jets to adjust. So they have on the nose and on the wings and everything. You know, you could talk about, well, why do they need wings? They have some sort of like aerodynamics, but you know, we've seen them engage in atmosphere as well, so that's important. But when they're in space, they have these little jets that just puff out air to adjust their trajectory, which is exactly right, because I've talked about this plenty of times before, but if this is the first time you're here and listening to science behind science fiction, you know, it's force equals MA. You have an action reaction, and if you want to change your direction, you're going to have an action, and then you have a reaction. And attitude thrusters is the correct technical term. See, sometimes it's just white noise when I try to think of technical terms, but that's okay. All right, so carrying on from that, they're brilliant, and that's what I love about the space battles. Not only are they fun to watch, but they treat space like the three-dimensional place that it is, which is fabulous and not seen a lot. Usually for just, I think there's been a lot of discussion on like space battles and humans on Earth watching them, that if you make it realistic for space, it doesn't make sense to the viewer. So when it comes to a trade-off between accuracy versus entertainment, if ships are doing things that you wouldn't necessarily expect them to do, and it could throw you out emotionally from the story, and remind yourself that you're watching something as opposed to being emotionally invested in that. And so sometimes when we're like, well, why do they have wings? Especially for like these Vipers, if they didn't fight in atmosphere, that's because wings tell us that it's a fighter jet. That's what we see them as. And yeah, to some extent too, it would be really boring. But I think Battlestar Galactica perfectly finds that balance between being like, no, this is a space battle, but it's still intuitive to us, and you still are able to be completely immersed in it, which is fabulous. They do I do like too, another kind of cool scientific thing that happened. Like I said, I'm kind of going chronologically, but there are just some highlights that I want to go through. So when they are in this battle and it does take out all of the Vipers that are there, I mean, they're just dead weight. It's crazy to watch that they just, and it's basically like a low-grade EMP. Complete interference, complete takedown of all of their electrical systems. And then all of these explosions happen. And because we're in space, you don't have atmosphere to stop explosions from continuing to explode. And that shrapnel books it. And it's not going to slow down. And it books it, and it hits Hilo and Boomer's craft and punches right through that. In fact, I think there was an article today. It's nothing new, but it's we constantly have to remind ourselves that even small, tiny objects in space, they go really fast. They can do a lot of damage, and they can punch through holes. If anyone's ever been to the Smithsonian Air and Space Museum that's on the mall, they have craft that they've brought back that you can see the damage that's been done and some of the holes that have been punched through. So they never go into the details. It's a good point, Zach. They never really go into the details. Initially, it kind of looks like an EMP, but they do this scan. So it seems to be some sort of active thing that they're doing. So let's go with it being, let's imagine that instead of an EMP, because it doesn't, it's a good point. It's not really a burst. It's much more of like a dedicated attack. And, but you'd have to be able to hack into it somehow and find some way to break into their code, which they kind of allude to later. So it's a good point, but they don't make it clear exactly how they were able to do it. And yeah, exactly. So, the explosion, all that shrapnel just tears a hole through the ship and through Hilo's suit, and explosive decompression happens. They have a really cool like seal that they are able to pull, so it's like they have protocol for holes being punched in their ship, which is awesome. Not to mention they wear spacesuits all the time. I mean, they're a combat support ship, which makes perfect sense. So they are mostly depressurized. They wear their spacesuits in combat, and then the shrapnel goes through, punches holes into it, and then and they're able to cover it. So it's not something that you want to happen, but they're obviously prepared for it, which is awesome. One thing that I really like, we've been talking about the let me see, Planades. Ooh, that's cool. I will have to check that out. So there's an anime called Planades that deals with debris in space. Also, one of the shows that I worked on, Orbital Redux, they had a really great plot line as well about, they were basically like space truckers and they got pummeled with debris. And yeah, so it is a problem, especially in low Earth orbit when you have these explosions happen. But the one of the things I like too is that, oh yeah, also gravity. Yeah. Oh, gravity. Space is really big. Gravity doesn't quite get that across. Yeah, I did. That is awesome. So one of the things that I really like is Apollo is able to, he uses the Viper to distract the missiles. So initially when we saw the missiles fire at the ships, they curve. And again, for me, sometimes we see this happening in science fiction, and it's not clear that it's necessarily tracking them, but they're more arcing. If it looks like it's arcing, that's not necessarily what would happen in space because there's no gravity. I didn't say it. And I love the way that they use their hyperdrive as a weapon, but that's for another episode. But when weapons arc in space, there is no gravity. So you send it up, it's going to keep going in a straight line. And so I kind of come to attention when I see that. But they make it very clear that these missiles are arcing because they're tracking. That they are tracking missiles. And Apollo is able to get in the line of them, move around enough, distract it, pick up the heat, and then carry it off and engage with the missile away from the ship. So that's how they're able to do it. And it's not easy. There are lots of methods of tracking interference that they can do. So he has to get really close to it to confuse the signature to have it. You basically want to fill up the field of view that they're using so they think that there's nothing else there and then have that follow them away. So that's how he's able to do that, which is pretty cool. Now, they don't have a lot of ships to engage, and Adama reminds them, he's like, there's a whole museum. And there you go. Oh, yeah. And Starbuck goes and helps all the mechanics and everyone get the old models of Vipers, which is important because, as we pointed out, they have not been upgraded. So Zach made a good point to the code that they are actually immune from the Cylon vroom, vroom, hacky pulse thingy that they're doing. And so they are immune from that, which is awesome. Now Battlestar Galactica gets nuked. I kind of forgot that happened. Yeah, it does, exactly. Kind of forgot that they took a direct nuke, and they do, and that ship can take damage, which is kind of its point, so I'm okay with that. But bad things do happen. They basically have an entire launch bay that has been nuked, and they actually say, like, the Battlestar Galactica, briefly Gata mentions that they are in an uncontrolled spin from the violent decompression that happened. So not only did the nuke hit them, and that is a force, and we're in space, so there's an action-reaction that it starts to spin, but then you also have, like, holes that are torn into it, and all of the air that's pumping out of it is sending the Battlestar Galactica into a spin. And it's also on fire, so that's not good. Now, it's a kind of upsetting scene, but the chief is trying to get his team, they're fighting the fire, he's trying to get them out of there so they can vent. And what they're essentially doing is exposing the fire to space so it doesn't have any oxygen, so it goes out. And a lot of us know this intuitively. Maybe not intuitively, that's the wrong way to say it, but we've been exposed to it before, this idea that fire needs oxygen, and if you deprive fire of oxygen, it will go out. If you put a cup over a flame, it will use up all the oxygen, and then it will put itself out. And this is a more extreme version of that. And we've talked before about how explosions in space in science fiction, what they would actually look like. And we've thought about it a lot. Because space stations, spacecraft, whatever, do have a lot of oxygen or fuel for fire inside of them. And so when they go kablooey, there is still going to be a big fireball that happens. But the big question is, how long does that fireball last? Because there's only the vacuum of space outside. So you're going to get all this stuff that flies off, but then you're also going to get this fireball that would go out a lot faster. So you don't get this sustained burn, which is kind of what we talked about. That is more what it would look like. But Battlestar Galactica handles it brilliantly. They say, we've got a fire on the deck, we're just going to open the vents, and a lot of people go out with it, and it's pretty upsetting. But the fire goes out because they deprived it of oxygen, so it gets taken out. So, science win. Now, another little offhand remark that they make that I like is when Boomer and Hilo, their fuel line got punctured, so they land on Caprica to fix the fuel line so they can take back off. They do have space, but it's not just they're limited by how much space they have, but they do have to monitor how much weight it requires to reach an escape velocity to get back off of the planet, which is awesome and completely accurate. And yeah, I mean, the Death Stars, that's exactly what I was thinking of. It's that sustained Death Star explosion. And if it just went, then it would be not as cool. I mean, kind of cool, but different kind of cool. So, you know, this idea that you have vertical takeoff, you still have anticlimactic. You still have a weight limit that you might not have enough weight to actually be able to take off. So, yeah, they did that pretty accurately, which is awesome. Can we just take a minute to appreciate we're at the halfway point? So let's take a minute to appreciate Laura Roslin for being awesome. And that swearing in ceremony gets me every time. When they realize that she's last on the list. She's 43rd in the line of succession, and she's the only one still alive. And they swear her in, and her trembling voice and shaking hand gets me every time. Her character is amazing. So good. So good. We love Laura Roslin. And that's our... yeah, it's bonkers. And she's on it, and she's the last one. So that was our midway fan moment. We love Laura Roslin. So now we are going to get to the big highlights that we have. So I think I had EMP in my mind because that's what they do later to confuse the Cylons themselves. Because now the Cylons are trying to take out all of their ships. So good. They are coming for everyone. And Apollo, remember, is with Laura Roslin's ship, the civilian ship. And Cylons are coming for them. And Apollo saw, I think, I'll try to remember it, but basically had the hyperdrive energy coils are stored in this. Yeah. Number one. Are stored in the bay. And he engages them to release all of this energy at once to be an EMP pulse that looks like a 50 kiloton nuke. Which is a decent nuke, but not insane. 1 megaton is kind of what we talk about when we talk about scary nukes on Earth. 50 kilotons is still, that's reasonable for weaponry, I guess, for like space weaponry. Yeah, 42. But it is the entire colonies. I don't know. So they probably have like each planet in between there as well. We're not here to discuss this. I mean, I will get into the politics of the 12 colonies, but that will take away from the cool science that we get to talk about. So he basically, he EMPs the crap out of everything. Everyone gets knocked out, which also is accurate. But the interesting thing is EMP is a big catch-all. I've already used it as a catch-all. It's just electromagnetic pulse. It's a big release of electromagnetic energy. And you can have different types of electromagnetic pulses that are released. You can have them in different frequencies, and you can have different waveforms. So like a quick burst, you can have like a burst that does that. You can have like a more sustained long term, like it takes a little longer to get to the peak, but maybe the peak would be higher. All of these are different types of EM pulses, pulses, EMPs, that it is a catch-all term. And I mean, we've seen it in a lot of science fiction and in this as well. Explosions are EMPs. They release electromagnetic energy, even if it could even just be radio energy, but that's still an electromagnetic pulse. So it could. I mean, it's such a catch-all in science fiction that you can kind of say, oh, we released an EMP and it did this, this, and this. And as long as it at least interfered with electric systems, human neurosystem, probably not. I mean, you know, they did get knocked out. Like, there was a physical impact from this, but I think that was more the jolt from the ship than anything. But, I mean, a good natural EMP is lightning. And lightning will knock you out. And Apollo was really close to that. So he kind of, I mean, we can say he got the equivalent of being struck by lightning. But he was fine. And I love, again, I wasn't done fanning over Laura Roslin. I should have known better. But she, I love her line where she's like, so that's amazing that it worked. He's like, yeah, that was always in theory. She's like, so I learned the lesson here is not to ask follow-up questions. That is a good lesson to learn. So, from here, though, that was one of the cool things. Now they're going to Ragnar. Now we're going to take a second and we're going to talk about the star system that they're in. And I think I have to get over here to show it. There is a star system map, and you should look up this map because this is not doing it justice. I couldn't even get it big enough to do justice on this entire screen, but you should look it up. The Battlestar Galactica star system is a bonkers star system. This is the 12 colonies of Kobol. I do not know how this star system is stable, but Kevin Grazier is a consultant on this, and he has talked at lengths, and you can read all sorts of cool stuff about it. But this star system is bonkers. It is 4 stars. It is 4 stars, 23 planets. They are in 2 binary orbits. So you have 2 binary stars, and then they are all in orbit around each other. So when they talk about their star system, it is a giant star system. Yeah. And I kept I'd known this, but then I'm trying to trace the way that they're talking about it here. And Adama is the Ragnar's on the other side of the solar system. And I'm like, what? So Ragnar is on one side of one of the binary star systems, but they say that even here, the 2 binaries, so the 2 stars and then the 2 stars, are 0.16 light years away from each other. That's nothing. I mean, our entire space is big, but when it comes to space, 0.16 light years is stupid close. Our one solar system, the amount of gravity that our star system affects goes out to 1 light year. Our Oort cloud, which is a bunch of dust that's, in a sphere because it's trapped in our sun's gravity, goes out to 1 light year. These stars are 0.16. So the orbital dynamics of this star system is a nightmare. But you have 2 binary systems, and then those systems are orbiting each other. And I'm going to get this off so I can sit in a comfortable position and not squish my face in here. But definitely look it up. It is super, super cool. So they have all of those. There's a lot of detail in that map, and it's awesome. So it is one star system, and Ragnar is now, in the pilot, in the mini-series, Ragnar appears to be some kind of nebula. It is actually, I double-checked this, that they kind of go back and forth with it. But technically, it is a gas giant. It is a very big gas giant that is on the edge of one of those, of the binary star system that Caprica is in. So they say we have to get to the other side of the star system to get to Ragnar, which is the weapons depot. But there's a whole Cylon fleet between us and there. And they're like, do you want to FTL jump? And they're like, it's been a really long time. They're like, we're going to hyperlight jump. And then I'm like, hyperlight jump. Because the hyperlight FTL jump drive in Battlestar Galactica is awesome. And they all start panicking because they haven't done a faster than light, they call it hyperlight faster than light. They say FTL jump or a hyperlight jump means the same thing. They're like, if we're off by a degree, we're going to end up in a sun, and they're not wrong, but they're only trying to jump a small distance, which I think is really interesting and really important to think about when we talk about Battlestar Galactica, because let's take a second to talk about what a jump drive is. And if you've followed me for a while, you've heard this. So get up, stretch, grab a drink of water. Those of you who haven't heard this before, we'll talk about it really quickly. So, we have space-time, and it's a flat plane, and if you want to travel from here to here, you have to travel along the whole surface of space-time, and it could be curved, it takes a long time. You can't go any faster than the speed of light. But if you want to travel faster than light, there are various ways that you can do that. So instead of let's not use that. I'll just use this piece of paper. So instead of going along the surface in a straight line, you fold it, you jump, and then you unbend it. And that's basically what they're trying to do. Now, warp drives are different than that. Wormholes are different from that. These jump drives are saying, I'm here, I want to go there. So I'm going to bend space-time to that point, make that jump, and then unbend. So the micro jumps, the comment about micro jumps being harder, they would sort of, for various reasons. It's one of those parameter trade-offs, right? That your accuracy, if you're saying, I want to go very specifically to this specific point, that is much harder to do because, so your micro jumps are because you're making a much more dedicated position-to-position jump. But it's easier to do in the sense that it doesn't require as much energy. So for all of that, if we're bending space-time, right? If you want to bend space-time, normally, if you think of the trampoline, navigationally harder. The trampoline here, bowling ball will bend space-time. Mass bends space-time. If you don't have the mass, you need an equivalent amount of energy to bend it. So in order to do that, you need a stupid amount of energy. And so micro jumps are easier because they require less energy, but harder because of the navigational difficulties that it requires. So they are just trying to go from one side of the star system to the other, but they can just jump it. So not only are they saving time, but they're avoiding the entire fleet, which is awesome. And this idea that they need to spin up the FTL drives in order to do that, also totally fair, because you are bending space-time while you're doing that. So before they can make the jump, they have to get that point in space-time to them. And that is going to take time and energy to do that. And then they can make the jump, and then it unbends. So that's a really quick rundown of how the FTL drive in Battlestar Galactica works, but the way they talk about it is brilliant. So I'm going to talk really quick about Ragnar, and then we're going to come back to the FTL jump drives because they have a really good point. So why that doesn't affect others in space-time between the points is a great question, and one that we kind of go when we talk about this. But if the way we can gloss over it is typically when we are bending space-time in various ways, like when we're doing warp drives or wormholes, or if we're talking about space-time in general, it could have bumps and ridges that we just aren't aware of because we just have our local space-time area. And for that, physics, you want to live on a locally flat plane of space-time. So if you're bending space-time from one point to another, everyone along the way, as long as their close points are still flat, then physics won't break for them. Now, the visuals that they use for the FTL drives, where it kind of does the whole thing, visually that's awesome. You could say that that's them transitioning from one point to another. But I think locally, as long as everyone's space-time is flat, then you're not going to break physics. As Laura Rosalind said, the lesson we learned here is not to ask follow-up questions, because then the science breaks down really fast. But you're absolutely right. I mean, this idea that then it just unbends, and so it's not permanently stapled together. Something like that would be like a wormhole. This is just saying that you locally bend it, and as long as at every point along there, those tiny local points are all still flat, then physics still works for them, then we're okay. Now, the issue would be if we had one ship here bending space-time, one ship here bending space to them. We're not going to worry about that. We're just, we can't science that because we haven't got to that point yet technologically in our lifetime. But we also have to try to get our head to wrap in 4 dimensions, which is also difficult to do. So, but good question though. And fun to think about. I mean, that's why we're here, right? It's all fun to think about. We're not ragging on it. It's just they come up with a really interesting way of going faster than light. Battlestar Galactica is not the only one that's done this. We have seen this in other sort of older science fiction, but also Dark Matter uses the blink drive. The blink drive is FTL jump drive. In fact, they actually have the best visual of it I've ever seen, where they actually show space-time bent jumping between the 2 points. And so the Dark Matter blink drive and the Battlestar Galactica FTL jump drive is scientifically the same concept, which is cool and fun to think about. So, they're at Ragnar, which, yeah, exactly. Ragnar, there's this station there, this munitions depot that they're trying to get to, and it's just orbiting. So, like I said, I think at one point they throw out the word nebula, but it's a gas giant. It's a very big gas giant. So one of the things that is cool with this is that when you think about gas giants, right? They're within the cloud, and there is no surface. So nebula just means cloud. In space terms, we can that's why it's kind of confusing the way that they talk about it. But there's no surface. So if you were to try to land on the surface of a gas giant, you would just go further down. And like them, it's cloudy. It's hard to see. It gets thicker and thicker and thicker. And then it gets really opaque. And then it gets really dense fog. And then it will start to feel like you're in water. And then it'll just get more and more dense and harder to move. But at no point have you actually landed on the surface. It's just you're kind of subsumed by dense liquid. Just sounds horrible. But that's the idea behind it. And so Ragnar is a base station, a munitions depot that is pretty deep within these clouds in Ragnar. One of the interesting things that stood out to me with Ragnar is the fact that they have rotating sections. And this stood out to me because we typically see rotating space stations as a form of artificial gravity in science fiction. That you have rotating segments and then people are walking along the outside. And to the extent that they kind of do a nice shout out, maybe a little bit lighter of a word for shout out, but they do a nice homage. That's the word. They do a nice homage to 2001: A Space Odyssey in the opening of this miniseries with Starbuck jogging through the space station in the same way that 2001: Space Odyssey opened with that. But even though it looks like Ragnar has these rotating arms and these rotating segments, at no point does that appear to be artificial gravity. And in fact, at no point I can think of in Battlestar Galactica do they even address their artificial gravity systems. Because as awesome and as realistic as the Battlestar Galactica is, it needs to have artificial gravity somewhere. They would just be floating around in space. So yeah, I mean, we can think about it. Helping to maintain orbit is a good way of thinking about it. It could also be a power generator system, right? That it's using one of the things that I thought of is maybe it's using the winds to generate power. Could be spin stabilized. Yeah, because they were orbiting opposite each other, so it could be stabilizing it because it is just floating in clouds. So y'all are smart. So I like these ideas. But yeah, at no point do they talk about it. And they do seem to actually access the center point. And if those outside arms were artificial gravity, then the center point wouldn't necessarily have gravity. But then also this is around a planet. So it could be close enough to the center mass that you still have some downward gravity. If it's, again, they kind of treat it like a nebula in the show. In the resources for the show, they say specifically it's a planet. So if it's a planet, it could be close enough that it has decent gravity and won't need artificial gravity. And that spinning could be spin stabilizers. If we didn't have the background resources and maybe thought that this was a nebula, then it would need some form of artificial gravity. But again, at no point does Battlestar Galactica, the show, ever address how they have artificial gravity, which is fine. I think, as a scientist who does science consulting, sometimes you're better off just not explaining it. You're going to get yourself in more trouble if you try to explain where this artificial gravity is coming from than if you just never mention it. and you all have artificial gravity and it's all fine and let's just all go back to our corner and we're quite happy. So it's interesting to think about, but it doesn't seem that those rotating arms, they're a nice sci-fi visual, but it's not artificial gravity. And there is a lightning storm here, which is cool. And we have actually discovered lightning storms in space, where you get basically static between clumps of gas that create some form of lightning storms. Yeah. Right. I mean, lots of issues could come up with it. And I mean, it's been a while, and I don't really remember Battlestar Galactica ever mentioning how they have artificial gravity, which is fine. I'm okay with that. Now, there is kind of a cool storytelling element that they have, that this fuel refinery is exposed to a high amount of thallium, but it's a component that is high. Oh, the fuel refinery has a high amount of thallium, which the ships need. Sci-fi techno stuff. But the nebula, the planet, contains an element that is degrading to Cylon tech. Now, they talk about these silica touch points. So it has some effect on silicon, but I imagine that it goes deeper than that, that somehow how the Cylons are wired up, that because they talk about these silica interfaces, that's what degrades when they're here. And they have used that. They did specifically build this munitions depot in this planet because of that. So that was a known thing to do. And then this guy is there, whom I hate, thanks to the rest of the series. And I will say that strong word quite strongly. I hate that Cylon. And he's not feeling so good. And that's what tips off Adama that he's a Cylon. Because they consciously built Ragnar in this planet that has a component, again, they never went into. Sometimes that's smart. Don't try to over-explain it. That is degrading to Cylon systems. So, then they say, all right, we've got our munitions depot. The captain is alive, and we've learned that Cylons look like humans. Crap. Let's get out of here. Let's peace out. And they have acquired all of these colony ships, and they come up with an awesome, where they're all hiding. The colony ships show up, and they're like, hey guys, we need help. And Laura Rosalind is like, I'm the president, you will help us. And there's great, I love Battlestar Galactica. The civilian ships show up, Galactica's like, you're on your own, guys. And then everyone else is, that's maybe not. And Laura Rosalind points out that they need to start making babies if humanity is going to survive. So the Battlestar Galactica is going to be the support and the defense for the civilian fleet. They cannot FTL jump out of Ragnar from the inside. So they say there's too much electromagnetic interference from the storm. And you could see that there are lightning storms happening. Lightning storms happening just in nebulas are rare if the nebulas are primarily just hydrogen and helium, which is what we mostly see in space. If there is a high presence of dust and heavier elements, so likely what is called a planetary nebula is left over when lower mass stars reach the end of their life, you are going to get clouds that have heavier elements in them. Scientists, even up to a decade ago, were like, there's no way there's lightning in space. Starting to soften on that a little bit more now. Regardless, Ragnar is a planet, so these clouds do have, we think, some probably heavier, dustier things. Because the lightning storms are really static discharge. It's kind of what's going on. It's a little more complicated than that, but that's a good way to think about it. So there has to be some way to build up enough static that it would need to discharge. And this lightning storm, when it discharges, remember I said lightnings are a natural EMP, that would make sense for there to be too much EM, by which they mean electromagnetic interference. Oh good, I hope it wasn't me. Anyway, this is recording, so if my internet glitched for a little bit, then it's on YouTube. But they have to get out of the planet before they can actually jump, because there's too much electromagnetic interference. And the drive coils, remember, require a ton of energy to spin up and figure out where they're going to go. So they have to get out from the cloud system. Now, the last thing I wanted to talk about is they throw out one line here that is awesome. And they say, And yes, thank you. Yeah, they can cause arcs when they go to dock in space. But we only have a couple minutes. So, but yeah, that is a thing. Static discharge is a problem. So they say, we're going to jump to the Promar sector. Problem, it's past the red line. What's the red line? That's all they say about it. That's going to be really hard to do. And then they're like, oh, Gata, you can do it. Okay, the red line is a great concept. Remember, when we're talking about FTL drives, we're trying to go from point A to point B, and we're bending space to get there. Light travels in space, right? Light, when we're looking at what is at this point, we are looking at it from here. Light has taken time to reach us. So if we are traveling somewhere that is, let's say, a couple light years away, we are seeing it as it was a couple of years ago because that light has finally reached us. So you can predict where stuff is now. It's called proper motion is the astrophysics term for this, but you can observe the proper motion of objects in space. So let's imagine this is a star. We're here. We want to jump to this star. We see this star as being here, but its proper motion means it was here when the light that we got showed it, but it's moving through space. So by the time we got the signal, the star is actually over here. But we can observe what that proper motion is. So we can say, okay, even though it appears to be here, we know that right now that star is over here. So if we want to jump to this position and not end up in the star, we have to predict where that object actually is. And that is possible to do. To a point. There is this thing called chaos theory and nonlinear dynamics that makes things harder to predict the farther out they are, because small changes can cause big differences. And so the further away something is, yeah, we might know its proper motion, but there could be something that interfered with it that makes it not be where we think it is. And that's what the red line is in Battlestar Galactica. Now, it's a pretty accurate government show, like depiction of military and the Marines and government. So let's just say that their red line is like 99% certainty, right? We're gonna, or 95% certainty, but that they are saying our red line is the point at which we can only say with a 99% accuracy that we know where everything is. Past that, we can predict where stuff is, but it's too far away, and chaos theory tells us that we can't know for sure exactly where everything is, and we don't want to jump into a star. So if you are trying to figure out where your ship is going to land, there's going to be a limit to where you can confidently say you know where everything is. And that's where the red line is. And I freaking love it. And that's where we are going to end this. They do have a limit to jump distances. They absolutely do. Just from the amount of energy that they can store. That's all it is, because FTL jumps require require a lot of energy to do them. And that energy is going to be limited by how much you have. But even then, you still, I think they've implied that the red line is closer than their energy limiter. So, which I think they get into in a lot more detail in the first episode, season 1, episode 1, where they talk about where they're having to do all those regular jumps to try to stay one step ahead of the Cylons. So I'm glad that makes sense. Awesome. All right. Well, thank you guys for hanging out with me for the past hour. Thank you all. I really appreciate it. Battlestar Galactica is just awesome. And really the highlights are this freaking star system that they have, the 4 stars, 29 planets, 23 planets, bonkers. And their nuclear, the way they talk about nukes and radars, their EMPs, their the fact that these old Vipers don't have the code updated, so they are able to survive the Cylon interference, the Cylon hacking, the weird Ragnar planet that they're at, and then the FTL jumps and the red line, which are like my favorite things ever. So thank you so much. I'm glad you had a good time. Remember all my social media stuff if you want to interact, if you want to ask more questions, or I will be posting this onto my YouTube, so you can find it there if you missed part of it. If you want to see it later, the link to it is down there as well. Also, a link to my Patreon is down there, and if you are interested and so inclined, thank you for the follow, part of the commander level Patreons get my notes, get copies of my notes that I take for all of these shows. But at the bare minimum, you do get to vote on what we talk about next. And next week, we are going to be talking about the science in Avengers Endgame. So be sure to follow here or subscribe if you're on YouTube. And thank you again for hanging out with me today. Yeah, I am glad I can make people's evenings, work shifts, whatever, a little bit more interesting and fun. And thank you if you were here and weren't engaging in the chat. I still really appreciate you spending time with us and listening to our fun, geeky conversation. So I love you all. Get up and stretch. Have a glass of water. Take care of yourselves. Take care of each other. Live long and prosper. All right. Until next time. Thanks. Bye.